All right, so we've multiplied radicals and then we simplified quotients. So now we are going to add and subtract. Adding and subtracting radicals is very similar to adding and subtracting or combining like terms. Your radicals are just going to act like the variables. So when we combine like terms, remember we find things that match. So number one, these two terms match because they both have an x. So 3x plus 7x is simply 10x. So all it is you combine your coefficients, the numbers that are being multiplied, and the variable just comes along with it. When you have one like number 2, you need to find the things that match. We usually start with our variables first. So 2x and 4x match. 2x plus 4x would give us 6x. It's helpful to cross those things out. And then you have 5 minus 3, which would be positive 2. So 6x plus 2. So just reviewing what it's like to match up like terms and combine them. If it's an addition, add them. If there's subtraction, then subtract them. So when you are adding and subtracting radicals, you can only combine terms that have the same number under the radical sign. Okay, so your first thing is to simplify your radicals if needed. So this goes back to the very first set of notes where you need to find perfect square factors and simplify them down. Okay? So you can only combine terms with the same number under the radical. So if you just look real quick at number 1, you don't have to simplify because those already have the same number under the radical. So the radical, the square root of 7, is basically like the x up here. All right, so for step 3, or rule number 3, you combine the coefficients. And the square root part stays the same. So sometimes it's helpful to have kind of an in general. So what we would have is a square root of b plus or minus, either one, c also square root of b. So first things first is you need to make sure that the numbers underneath the square root match. That's how you know they are like terms and you can combine them. And then you simply do whatever it says just to the front number. So you would have a plus or minus c, whatever that is, times the square root of b. So the square root of b just comes along for the ride basically, just like the variable does up in the review ones. So number 1, like I said, these two already match. If it's helpful, just think of it or even cross it out and think of it as an x. You have 4 square roots of 7 over here and 5 of them over here. So that would be a total of 9 square root 7. That's it. Number 2, the numbers under the square root already match. So then you just do the outside numbers. 9 minus 12 is negative 3 square root 13. Done. Now, of course, they can't all be that easy. So when we start to look at the rest of them, we notice that none of the numbers under the square root match. So your job is to make them match, essentially. So you're going to have to break down the square root of 20. Now, here's kind of a hint. you should know that 5 needs to stay under there. So if you do 20 divided by 5, it should be a perfect square, and it is. So I like to do this off to the side. The square root of 20 is 5 times 4. Square root, square root. The square root of 4 is 2 comes out in front, square root of 5. So I'm going to rewrite the whole problem. Some people just like to cross that out and put that up above or down below. It's up to you. But my new problem would say the square root of 5 plus, and instead of square root of 20, because we can't put those together, we change it to 2 square root of 5. All right, now a lot of people think the answer is just 2 square root of 5, but don't forget there's technically a 1 out here. So 1 square root of 5 plus 2 square root of 5 would give me 3 square root of 5 for my final answer. So again, in order to combine them, in order to add or subtract, they have to look alike. They have to have the same number under the square root sign. So you need to simplify first in order to be able to combine them. Now that one helped because it already had the 5 underneath. This one doesn't help because it does not have both 12 and 27 need to be broken down. All right, so 12 is 4 times 3. Square root, square root. Square root of 4 is 2. Bring down the square root of 3. Once you get the first one, you should know, okay, there should be a 3 left over in this one. So if you do 27 divided by 3, you do get 9, which is our perfect square. So 27 needs to be 9 and 3. Square root of 9 is 3. Bring down the square root of 3. Now they match. Don't forget to bring the sign down. So 2 square root of 3, which is the same as the square root of 12, minus, we change square root of 27 into 3 square root of 3. So now that they match, we can do 2 minus 3 to get negative 1 square root of 3. Notice I didn't put the 1 in front of there. You don't need to write the 1. You can just write the negative sign. Again, I haven't showed you, but you can be checking all of these by typing in the original problem and then typing in your answer. Make sure they give you the same decimal. This one gives you 3 terms. This first one is down to the square root of 5, so that should help us figure out that there's a square root of 5 in each of these. All right, so again, if you want to write it off to the side, that's fine, or you can just do it here. But we should know that 5 is going to go in, and 16 times 5 gives us 80. So again, you want to keep trying. You can always just start with your perfect squares. If you do 80 divided by 4, you're going to get 20 though, so you're going to have to keep breaking it down. So that's why it's helpful to see, oh, that 5 is in there, so hopefully 80 is divisible by 5, and it is. Square root, square root. The square root of 16 is 4, square root of 5. So these two actually were the same thing. So I'm going to rewrite this first one. Okay, so that's this one. That's this one. And then I still need to do 20. So again, since 5 is in both of those, you hope 5 goes into 20, and it does 4 times. Square root, square root. Square root of 4 is 2, square root of 5. And we need to bring down the addition sign in between all of them. So now that they all have the same square root, they all match, we can put them together. 4 plus 4 is 8 plus 2 is 10. Square root of 5 is our final answer. All right, our last one. Again, when we're looking, hopefully we just know that's 4 times 11 anyway, but we see the 11 in here, so we are pretty sure that this is going to break into an 11 somehow. So this is 4 times 11. Square root, square root. Square root of 4 is 2 square root of 11 minus 2 square root of 11. That's just 0. Technically, you could write 0 square root of 11, but 0 times anything is just 0. So I want you to have 0 as your final answer. So again, in order to combine, to add and subtract, you need to make sure the number underneath the square root matches. In order to do that, you need to find those perfect squares that go in and simplify them, and then you just combine the front numbers, the coefficients.